Hi, my name is Hayden. This is day 14 of doing Leetcode until I get a job. I'm still unemployed, and this is Leetcode 3396, minimum number of operations to make elements in an array distinct. Okay, this is an easy. We are given an integer array in nums. We need to ensure that the elements in nums in the array are distinct. To achieve this, you can perform the following operation any number of times. We can remove 3 elements from the beginning of the array. If the array has fewer than 3 elements, remove all the remaining elements. And then note that an empty array is considered to have distinct elements. We want to return the minimum number of operations needed to make the elements in the array distinct. Okay, this problem is basically asking us, how can we make the elements in an array distinct if we can just remove the front 3, or what's the minimum number of operations we need to make the elements in the array distinct if our operation is removing the first 3 elements in the array. Okay, so this is a pretty easy question. We can just kind of go through this and look right now just to understand the problem. We would remove these 3 elements because 2 and 3 appear later. Alright, so these are off the table. 4, 2, and 3, 3. Alright, there's a repeat of 3, so we're going to remove these 2 elements. And we're going to be left with just these elements, 3, 5, 7. How are we going to implement this? Well, when in doubt, hash it out. Alright, we're going to use a hash map to collect a count of all of these numbers, and then as we're getting that hash map, we're going to increment something that counts the number of duplicates we have. Alright, so let's quickly make our hash map. Okay, so we're just going to call this, we'll call this counts. Okay, and this is going to be 1. So we see 1, we're going to make an entry for 1. Alright, 2, we're going to add an entry for 2, so there's 1, 2. 3, same thing. As we iterate along, we see 1, 3. 4, 1, 4, cool. Alright, 2. Alright, this is our first duplicate, so first of all, we're going to adjust the value in 2, and we're also going to have our num dupes, and we're going to increment that because we have just found a duplicate number. Okay, let's continue. So now we're at this 3. I think that's index 5. So we're going to erase this 3 because we found another 3. So we're going to make this a 2. So there are 2 3s. Alright, 5. There's no 5. Oh, and then I made a slight error. There should be 3 3s. Alright, and then 1 7. Let's just scoot over a little bit. Okay. And then the number of duplicates, as we found duplicate 3, we're going to increment this by 1. So this is going to become 2. Alright, cool. With this information, how are we going to determine how many elements or operations we're going to use? We're going to once again iterate through this array. So we're going to iterate through this array, but just decrement. We're going to iterate this array essentially until there are no duplicates left. So we're going to go through 1, and we're going to remove the 1 count. Okay, let's remove the 1 count. Alright, now 1 is 0. Cool. Has num duplicates changed? No. Let's go to 2. Alright, let's remove this count, and we're going to make this a count of 1. Oh, cool. We just went from 2 to 1, which means that we just removed a duplicate. We're going to erase 2. And we're going to have 1 num duplicate left. Alright, for 3, same deal. We're going to decrement its count. 4, we're going to decrement its count. 2, we're going to once again decrement its count. We're at 3. We're going to once again decrement its count. Oh, Cool, we just went from a count of 2 to a count of 1. This just got rid of a number duplicate, or one of our duplicates. Now because we're at 0 duplicates, we end this iteration. So now we're left with this. This is our remaining array. We saw that our left elements, so 0, 1, 2, 3, 4, 5, we see that excuse me. We see that the elements that we stopped at is index 5, so we're going to call this index equals 5 that we stopped at. And then we're going to actually increment it 1 because why not? If we increment it 1, this actually makes it much easier for us later on. So left is at 6. This is the first valid element of our array. And now the answer is simply going to be 6 divided by, or let me redo this, 6 divided by 3. And we're going to take, I don't know what that is. And we're going to take the ceiling of it. So I might just make this a little bit prettier. 6 and 3, 6, 3, and this is going to come out to the ceiling of 2, which is equal to 2. So this is going to take us 2 operations. If this were instead at index 7, let's just humor ourselves. The ceiling operation is nice because this becomes 2.3, and then this is going to equal 3 because it's going to take 3 operations. Because let's say that there was a 3 here, we'd have to get rid of this one too. So it's going to take 3 operations. Alright, cool. So that's our solution. Let's quickly check out the code. So like I said, we're going to get the counts and the number of duplicates. Simple enough. If we encounter a count that is already 1, we're going to increment num duplicates because we're going from 1 to 2. And then we're also going to increment the count. And then we're going to find the index where there are no duplicates to the right. And we're going to go nums equals what's our number? If our count equals 2, we're going to subtract num duplicates, and then we're also going to increment our left, and we're going to decrement the count. This is just doing the process we described over here. And this left plus 1 is also this little additional plus 1 that we did on this index to go to here. And then we're going to iterate until the nums duplicates doesn't equal 0, or while it doesn't equal 0. So basically until it equals 0. And then this is just our little operation at the end to seal the deal, the sealing of the left index divided by 3. And if I submit this, we see that it passes. Alright, so what's the runtime on this? The runtime is going to be O of n. We're doing 2 loops through the array. So that's simple enough. And then because this is a hash map, indexing into this is only going to take O of n times. So this is O of n times 1. And then addition is also O of 1. So this is O of n iterations. And then for our space complexity, this is actually I'm going to name this D. D represents the distinct elements inside the array. So inside our counts. So as we see, counts only gets as large as the number of distinct elements in it, or in the nums array. So in the nums array, there's 1, 2, 3, 4, 5, 6 unique elements. And even though there's 9 elements in the total array, we're only worried about the distinct in this counts. So the space only goes up to the number of distinct elements in it. So yeah, this was Leetcode 3096.